This demonstration is about the classification of digitized neuroblastoma histopathological images as undifferentiated, poorly differentiated, or differentiating based on the grade of differentiation. Grade of differentiation is one of the most prominent morphological indicators in the classification of peripheral neuroblastic tumors. In this demonstration, we'll try to show how the proposed computerized system will work for automated classification of digitized neuroblastoma images. Here we have sample ROIs captured at 40x magnification from H&E stained tissue samples associated with all three subtypes, namely the undifferentiated, the poorly differentiated, and the differentiating case. As we can see, images associated with three different subtypes have different morphological properties. We can select any one of this, and for this demonstration I'll be going for the undifferentiated case. The computerized analysis starts with the segmentation of the given image into the cytological components such as the nuclei, the cytoplasm, the neutrophil, the red blood cells, as well as the background regions that do not correspond to any tissue structure. We can select the different methods to perform the segmentation, namely the k-means and the FCM. And the number of clusters is fixed to 4 that correspond to the number of cytological structures. The segmentation is performed using the color and texture characteristics of the pixels associated with each cytological component. Once we hit the segmentation button, the cytological components will be shown in a false color mode where the nuclei regions are shown in blue, the cytoplasm in cyan, the neutrophil in yellow, the RBCs in gray, and the background in red. We can click the nuclei, the cytoplasm, the neutrophil, and the background for seeing each segment separately. We can change the display option to plot the boundaries of each cytological component of the original image. For example, I have clicked the display option here, and I would like to see the boundaries for the nuclei. So it displays the boundaries just with the nuclei in focus. As you can see, these boundaries mark up the nuclei, and when you click on and off, it just appears and disappears. After the segmentation step, we can apply the classification by clicking the classification button. The classification is based on the features extracted from each cytological component and will write the output at the text area under the image. As we can see, it concludes that it's an undifferentiated case, and which is correct as when we started when choosing the image in the first place. More details about the proposed approach can be found in our related publications on our web pages. Thank you.